Hi, and welcome to Allen High School's discussion of bonding at the pre-AP or 10th grade honors level chemistry. We are in the midst of doing Lewis dot structures. I'm not going to do all of these examples because I want us to practice in class, but I want to do just a few more to help you along. Let's start with this one. Nitrogen has 5 valence electrons. It's in 15. It has 2 S's and it has 3 P electrons. Let me do 2 hyphen and 3 hyphen because that's not a configuration. I don't want you to get confused. I have 3 chlorines. They each have 7, so I have 26 electrons to mess with here. Nitrogen is my least electronegative, so I'm going to put my nitrogen in the center. Now I'm going to make my bonds 2, 4, 6. I'm going to satisfy my central, that's 8. Now I'm going to do my peripherals, 10, 12, 14, 16, 18, 20, 22, 24, that's 26. I lost count, okay, because that's 8, 8, and 8. Whoops, right there. There they are, 26. Now I've got 1 central, that's the nitrogen. I've got 3 peripherals, that's the 3 chlorines. You know, the peripheral, there could be more atoms, so it could be a peripheral group hanging off as well. Now, I also have 1 non-bonded pair. Remember, we're only counting those on the central atom. So that'd be AB3X, okay? Now, let's go on to the next one. I want you to see some that are deficient and some that have a double bond. So I'm going to jump down here to CO2 first. So I've got COO, and I've got 4 valence from oxygen, group 14, it has 4. 2 oxygens, they each bring 6, so that's 16 electrons. Now, if you don't follow kind of my guidelines with the 2 for you, 2 for me, you could get a less likely possibility for this one. So watch carefully. 2, 4, fill up the bonds. 6, 8 fills up the peripherals. Now 10, watch how I'm going back and forth. Because they're the same atom, you want to make sure, or the element type, you want to make sure that they're distributed equally. So 8, 10, 12, 14, 16. Now here's where we run into a problem. Neither oxygen is satisfied. Carbon is. So you look to mama and you want to share some more. And here's what some people do. They would go on to the central and they would take these 2, assuming my eraser is going to work here. There we go, of course. Okay, they're going to take these 2 and they might move them over. But that doesn't do anything for us because now the carbon's not satisfied. So what you need to do is take those and put them in between to share some more. All right? Now, that's what we need to do here as well. Remember I said you always look to mama for extras. Oxygen's deficient, so you look to mama, take that free pair, that non-bonded pair, and put it between. Don't move it over, put it between. Now, let's circle up here and make sure everything has 8. That oxygen has 8, this oxygen has 8, and the carbon has 8. Okay. Another way you could draw that is using 2 lines, 1 each representing that double bond. I don't like to use lines. Do not use lines on outer electron pairs. Only use line for bonds. Now I have a central atom. I have 2 peripherals. And because I've used those, there are no more non-bonded pairs on the central atom. All right, let's try this CO3 2 minus because this will also show us what we do when we have a negative charge. I have 1 carbon, it brings 4. I have 3 oxygens, group 16 brings 6. Now, this negative 2 is sort of like somebody said, man, I can't make it to the potluck, but here's a plate of brownies and a plate of cookies for you to bring to the potluck. So when it's a negative charge, you add 2 more electrons. So that's to compensate for that negative 2 charge. Carbon's the least electronegative, so put it in the center. And what do I have? I have 18, 24, right? 18 plus 2 is 20, plus that is 24. I know what you'll do. You'll tell me if I make mistakes. I need you to do that for me. Okay, make your bonds. Bam, 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 bam. I've used 6. Satisfy your central. I've used 8, 10, 12. Do the 2 for you, 2 for me. 14, 16, 18, 20, 22, 24. All right. Now, this oxygen's okay and this oxygen's okay, but this oxygen's deficient. It only has the 6. So we look to mama for extras. So look to mama. Don't move those over. Put those between. Okay. Now we're going to discuss where that double bond goes later on, but for now we're just going to leave the conversation there. With one last point, if it's an ion, you have to put brackets along with the ionic charge. Okay, now, had it been deficient, if it had been like NH4 plus, had it been a positive ion, we would have had 5 for the nitrogen, 4 hydrogens, they each have 1, and because it has a +1 charge, we'd lose an electron. That's kind of like somebody snuck in early and grabbed a plate of cookies and took it out. Okay. Now, the only thing I want to show you here is how we set up these carbons when we have this is called a hydrocarbon, only hydrogens and carbons. What you want to do is the carbons go in a row. You'll learn later if you get to take SL or HL with Mrs. Kulkarni some variations. But at our level, put those in a row and put the hydrogens around the carbons evenly. So 1 hydrogen for you, 1 hydrogen for me, 1 hydrogen for you, 1 hydrogen for me. Okay? Now, the carbon, there's 2 carbons. They each bring 4 valence electrons. 4 hydrogens each bring 1. So I have a total of 12 electrons to play with. Make your bonds. Remember, you got to get all those bonds. You have to have a bond between each of the elements. So I've used 2, 4, 6, 8, 10 valence electrons. And I'll put 12 over here, but if you notice now, hydrogens are fine, right? Remember, hydrogens only want 2 electrons. I can't emphasize that enough. But one of the carbons is not satisfied, so you got to look to the other to double bond. So we'd put 2 in the middle, and so that'd be a carbon with a double bonded carbon, and then there would be 4 H's on that. Now, in terms of the general ABX structure, you would define each one of these as a center. So this one has a center, and it has 1, 2, 3 things hanging off of it, so it would be AB3. This one, that would be a center. It has 1, 2, 3 things hanging off of it, so that also would be AB3. Okay, so that's how we would assign those structures ultimately to get at their 3-dimensional shapes. Now, what about ones that violate the octet rule? Well, with those, you're not going to have any choice but to put too many around, because bromine's got to go in the center. Fluorine can never be between 2 atoms. Just spread out the 5 bromines around it. So each bromine brings 7. I have 5 fluorines. They each bring 7. So that's 42. And this is going to be a long process, but I'll try to speed it up. Make your bonds. Okay, the center, that mama, is more than satisfied. It has 10. Didn't have to memorize it, just had to do it. And then go around and count. And I happen to know that fluorine cannot double bond, so I know that all of these fluorines are going to be a complete normal octet without any deficiency. A stands for the bromine. I've got 5 fluorines around it, so this would be AB5. Now let me show you ClF3. That might not appear on the surface to be an expanded octet, but watch what happens. Chlorine has 7. I've got 3 fluorines and they each bring 7. So that's 21 plus 7 is 28 valence electrons. So make your bonds. Satisfy the central. I've used 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I have 2 left over. What I like to do when I have 2 left over is I like to put a little line in there to show that they're on that central atom. Otherwise, it can actually get a little messy in the center there and it's hard to count. So I have the central atom that is chlorine. I've got 3 fluorines. And I have 2 non-bonded pairs on the central. We only count them on the central. So I've got that AB3X2. You notice that chlorine has 10 electrons around it. You didn't have to memorize that. If it's greater than or equal to period 3, it's possible. And if you follow the rules I've laid out, it'll just fall into place for you. Okay, the next discussion's a little more complicated, and we're going to wait for our next video. So until then, this is signing off.